All right, we're going to do vectors on the TI-89. Okay, I've given you a vector, a position vector I'm going to call R of t, which is equal to 3 cosine 2t, 3 sine 2t. And this is the x component, the y component. And we're going to find the velocity vector, the acceleration vector, and the speed as functions of time. Okay, so here we go. I'm going to clear my home screen. Whoop. Clear that out. All right, now, to input a vector into your TI-89, what we're going to do is we're going to use, instead of the angle braces that you would normally see on vectors, we're going to use this bracket here above the comma, which is the bracket that you would use for a closed interval. So here we go. We're going to go second bracket, and we're going to input now our position vector, which would be 3 cosine of 2t, comma, and now the y component, which is 3 sine of 2t, closing that, and we're going to close our vector. And so now the calculator has a vector in its memory defined as 3 cosine 2t, 3 sine 2t. All right, now what's really cool about this is that we can find the velocity vector pretty easily using the calculator. And what is the velocity vector? Well, it is the derivative of the position vector. So we're going to take the derivative using what we're used to, which is the differentiate button, which is F3, differentiate. And then I can go up here and grab my vector that I have inputted. And then I'm going to say comma with respect to time, close parentheses. And there is our velocity vector, which is -6 sine 2t, comma, 6 cosine of 2t. I chose that one because we could do that one without a calculator. I just wanted to do an easy one so that we would know what we were doing. All right, now we're going to find the acceleration, which would be the derivative of this function, of this vector, but we can use the position vector we already have because we have the nice technique here where we go inside the command and say, I want the second derivative by putting a comma 2, and then press enter. And there is our acceleration vector, which is going to be -12 cosine 2t and -12 sine 2t. So now we found the velocity, the acceleration. Now we're going to find the speed. Well, the speed, by definition, is equal to the magnitude of the velocity vector. Now, on the TI-89, we can do magnitudes of vectors. And to do that, we have to use something called the norm. The norm of a vector is the equivalent of the magnitude. It's another name for magnitude of a vector. Okay, so where do we find that command? Well, we're going to use the command above the math, the number 5, which is the math command. So to get there, we're going to go second 5. And then we have to go to the matrix menu. Now, it's way down low on the menu, so I'm going to scroll up to get to the lower part of the menu. And you'll see the norms are H here. So I'm going to go up to H, click norms, and I want the norm of my vector, so I'm going to choose number 1. And I want the norm of the velocity vector here, so I'm going to go up and grab this vector here with my calculator and press enter. And grab it and then close the parentheses and press enter. And gosh, well, the norm here is 6. Now, why is that the case? Well, when I square sine squared, I get 30 square this, I get 36 sine squared 2t plus 36 cosine squared 2t. And if you factor out a 36, because the magnitude of a vector, if I were to do this by hand, is equal to this component squared, the x component squared, plus the y component squared. And if I factor out a 36, we get sine squared 2t plus cosine squared 2t. And we're very happy to see that because that, my friends, is equal to 1. So the square root of 36 is 6. And so we verified that the calculator actually does indeed do a magnitude. Okay, so you could find the fourth derivative, which is jerk, if you just changed your derivative command instead of to comma 2 to comma 3 from the position vector. All right, now let's go, let's solve a problem that's a little bit different, where I'm giving you the velocity and I'm asking you to find the position and the speed and evaluate them both at t equals 2. Okay, so if I'm given the velocity vector, okay, I know that the position vector is going to be equal to, I'm sorry, the antiderivative here of each of the component parts. So we're going to take the antiderivative. I can do my integral sign here, of t cubed over 2 minus t squared dt plus, comma, the integral from the 5t plus 4 dt. All right, and then I'm going to have the calculator actually do that for me. So we're going to have to input our vector first. So let's do second above the comma there, and we're going to say t to the third divided by 2 minus t to the second, comma, which differentiates between the x component and the y component, 5t plus 4. And then I'm going to close my vector out with a closed bracket. Press enter. There's my velocity vector. And now I'm going to integrate it. So let's, how do I integrate it? I'm going to go up to the F3 menu, choose integrate, and then grab the velocity vector. I'm going to integrate it with respect to time. So I have to go comma t, because I've got to tell it what I'm going to integrate with respect to. And then I'm going to close the integral, and there we go. So we get r of t is equal to t to the fourth over 8 minus t cubed over 3 plus cx, which is the constant in the x component, comma, 5t to the second over 2 plus 4t plus a constant in the y direction. Okay? Now, we were given an initial condition here in the problem statement where at time equals 1, our position is 2, comma 4. So I can solve this for c sub x and c sub y here, the constants of integration, by saying r of 1 is going to equal 2, comma 4. So each of the components I can set, when t equals 1, I can say the x component is going to be 1/8 minus 1/3 plus c sub x has got to equal 2, because that's where we're going to be standing. And I can say that 5 over 2 plus 4 plus c sub y has got to equal 4, because that's where I'm going to be standing. That's my position in the y component. So if I were to solve this on the calculator, because of course I gave us icky numbers, because it's a calculator question. I'm going to go 1 divided by 8 minus 1 divided by 3. And what does that give me? Negative 5 over 24 plus c sub x equals 2. So c sub x is going to equal 2 plus 5 divided by 24, which is a nice pretty number, 53 over 24. Solving for c sub y, we're going to get 5 divided by 2 plus 4 minus 4. Those are going to cancel, so we're going to get c sub y equals negative 5 over 2. So I can rewrite my position function then as r of t is equal to t to the fourth over 8 minus t to the third over 3 plus 53 over 24, my beautiful number. And the y component is going to be 5t squared over 2 plus 4t minus 5 halves. All right, now we're going to verify that this is right, because I'm going to let t equal 1 on my calculator here. So let's grab the vector. You notice, though, when you do the integration here on the calculator doesn't put the constant of integration in there. You know, we have to be smart enough to know that when we integrate, we have a constant of integration. All right, so I'm going to edit this vector here that I had. and put my constant integration in there. So it would be plus 53 divided by 24. Whoops, I got to double divide here. I don't need that. All right, and then we're going to go 5t squared over 2 plus 4t minus 5 divided by 2. And there is my new position function with the t to the 4th over 8 minus t cubed over 3 plus 53 over 24. And we see that that matches my position. I'm going to go over here and make sure that that matches. All right. And now we can say what happens. I can go such that t equals 1. It puts us at 2, 4, which is what we needed it to be. So this is my position function now. So we found r of t. Okay, that's great. And I'm going to evaluate that at t equals 2 while I'm sitting here. At t equals 2, we're at the position 37 over 24 and 31 over 2. So we're at that position. This position vector is pointing at that position. Okay, next command, or next thing we're going to do is find the velocity. Now we have to find the velocity because, I'm sorry, we have the velocity already. We're going to try to find the speed. So what do we know about speed? Well, we know that speed is equal to the magnitude of velocity. Okay? And so I'm going to do that on the calculator using the command that we just learned, which is the norm. Okay? So we're going to find the norm. Okay, so how do I get to the norm command? Well, we go back to the second math, which happens to be above the 5. So second math. And we got to go to the matrix menu. Oops, I'm sorry. Second math, matrix menu. And I'm going to go up because it's that letter H for norms. And I'm going to press enter. Now I want to go back up on my calculator here and find the velocity vector that I inputted. And there it is. That's the original velocity vector if we go back to the beginning. Everybody see that? And I want the norm of that vector, so I'm going to press enter. And I'm going to close the parentheses for the norm command and press enter. And it's busy because it's going to be pretty complicated. And I chose one that was complicated because it's a calculator question. Okay? Because that's what we're doing. We're finding the norm. Okay, so let's write that out. Try to get it all on the same screen here. So this will be the square root of t to the 6th minus 4t to the 5th plus 4t to the 4th plus 100t squared. I scroll over plus 160t plus 64. All over, it looks like just the lonely number 2. Okay, so divided by 2. So that's the speed as a function of time. So if I want the speed evaluated at 2, I'm just going to let t equal 2. All right, so here's my calculator. And I'm going to clear that out and just grab this expression that I calculated for the magnitude and go such that t equals 2. Then we get 14, which is a nice number. So it's 14 units per time. That's pretty cool. Now, if I wanted to know the distance traveled between 1 and 2, that is the integral of the magnitude. Between 1 and 2, that's going to be the integral of the magnitude of v of t dt from 1 to 2. So we're integrating the speed here. And this is, again, a norm on the calculator. Okay, so I'm going to pretend that I am doing this without knowing what the speed function is as a function of time. I'm going to use the velocity vector and the norm feature, okay? So the first thing we have to do is find the integrate button. So I'm going to integrate, which is number 2. I mean F3, 2. And I'm going to integrate the norm. Well, how do I get to the norm? We go to the second math, which is above the number 5, and we go to the matrix menu. And we're going to scroll up because we know that norms are at H. And I want the norm of what vector? Well, I want the velocity vector, which I'm going to scroll back up in my history here and grab my velocity vector, which is right here. I'm going to close that because the norm is the square root, because it's a magnitude, of the velocity vector component squared. You know, so it's the square root of t cubed over 2 minus t squared, quantity squared, plus the square root of 5t plus 4 quantity squared. And we're going to integrate this, comma, with respect to t from 1 to 2. Because that's, you know, we're finding the distance traveled. So the length of the speed. And it's thinking. And it's thinking. Let's hope it does what we need it to do here. But anyway, it's really cool that the TI-89 can do vectors, and it's really, really helpful on the exam to be able to know how to do that. So the distance traveled is, what is that, 11.511 if I'm rounding units, whatever the units are. Okay, so that's my quick lesson on how to use the vectors on the TI, or do vectors using the TI-89, and you guys have a great night.